In this session, we'll give you a quick overview of data relationships in OutSystems. We'll start by looking at why relationships are important. Then, we will learn about the entity and reference identifiers, which help us define these relationships. Finally, we will get to know the types of entity relationships in OutSystems. When we are modeling the data for our application, it is very uncommon to have that data isolated. Most of the business concepts of our applications are related with each other, so it is very common to establish relationships between the data. These relationships can actually be as important as the data itself. Here we can see an example of a data model, with several entities. We have the customer, with simple attributes such as name, email, or address. And orders with description, due date, and the date of shipping. Besides these individual attributes that define each entity, we know that a customer can place multiple orders and an order has a customer associated with it. In this data model we have a relationship between the customer and the order entities, with the information of the customer, or requester, defined as the requested by attribute in the order entity. Creating relationships between data in OutSystems is mostly based on entity identifier attributes. To allow a relationship, an entity must have an identifier. The entity identifier is automatically created when the entity is created, and it can be identified by the icon with the red stripe and by its name ID. By default, the ID is created as a long integer and set as auto-number, so that every new record added to the database will have a unique number to identify it. The identifier attribute is mandatory. All these properties can be changed, including the mandatory property and the data type, which can be text, an integer, or even another entity identifier. It is important to know that changing the type of the entity identifier may require the ID value to be explicitly set, since the auto-number property may no longer apply. The identifier attribute can also be deleted if needed, but then it will not be possible to create a relationship with this entity. The entity identifier represents the primary key of the underlying database table. OutSystems supports simple primary keys and no composite keys, meaning that only one attribute can be the identifier. Entities can then be referenced by their identifier. To reference an entity, we need to create an attribute of type entity identifier, with the entity here being the one we want to reference. In this particular example, an order will have a priority, which is also an entity of our data model. So, the order entity has an attribute called priority of data type priority identifier. These attributes can be mandatory, or not, and static entities can only reference other static entities. An entity can also have multiple reference attributes. These reference attributes represent the foreign key in the underlying database tables. Every reference attribute will have by default the null identifier, value respective to its data type, meaning that for integer identifiers its value will be 0, while for text identifiers the value will be empty text. OutSystems supports three types of data relationships: one-to-many, one-to-one and many-to-many. The one-to-many relationship is created by adding a reference attribute to one of the entities. In this example, since a customer can place several orders, and each order belongs to a single customer, the order entity has the requested by attribute, which references the customer that requested the order. The one-to-one relationship is created by setting the data type of one of the identifiers to be other entity identifier. In this example, since an order can only have one receipt, the order receipt entity has its ID attribute as order ID, with type order identifier. So, when the order receipt entity is created, we just need to set its ID to the type order identifier. This way, the ID of the order will also identify its receipt. The many-to-many relationship is created by adding a third entity, with its own identifier, and two reference identifiers to the entities within the relationship. In this example, since an order can have multiple products and a product can be part of several orders, a new entity order product is created, with its own ID, and a reference attribute to the order and another to the product entity. As it can be seen in this example, it is very common that an application's data model has these three types of relationships defined, to better relate its data and its concepts.